Okay, recording. Welcome America, welcome Justin Bieber. Today we are going to be graphing rational functions and doing some more stuff with rational functions. Okay, let's go ahead and start with graphing. I'm going to attach this worksheet and we are going to start with number 3. Okay, so the first thing we look at when we're graphing this is, okay, in our denominator we've got a trinomial. We should probably go ahead and factor that and take a look for vertical asymptotes first. I like to draw the asymptotes, the vertical and the horizontal asymptotes first. So we factor that. You can hear the music next door. It's going to be x times x, right, because that's x squared, and it's going to be plus plus because we've got a plus 4x and a plus 4. So now, what two numbers? When we multiply, we get 4, but when we add the outer and the inner, we end up with 4. That's kind of nice. That ends up being a 2 and a 2.
Wait, is that for plus and minus?
Yep, just like the last problem we did.
Oh, duh. Oh.
So let me rewrite that as -1 over x plus 2 quantity squared. Kayla, we're graphing.
Oh my god.
I know. So exciting. All right, now we can see we've got a vertical, just like the last problem, we've got a vertical asymptote at -2. Because if I plug in -2 for x here, -2 plus 2, this denominator will be 0. We have no graph there. So I'm going to go ahead and draw that in first. And I usually like to use a different color for the asymptotes. But I've got a vertical one at -2. And it's actually got a multiplicity of 2, which tells us something about the graph.
Wait, what does that mean? Thanks for changing my file.
What does what mean?
The wrong word you just said.
So when you have this is not really in our curriculum, it's more for math analysis, but it's super useful when you're graphing. When you have more than one factor, so a multiplicity of 2, so there's 2 of them at this location, what that means is the graph is going to be approaching the asymptote from the same direction. So basically either the graph is going to be going like this or the graph is going to be going like this. It's not going to be going opposite directions like this because the multiplicity is even for that asymptote.
Okay.
So it's nice when we're graphing. So now horizontal. The horizontal asymptotes are the trickier ones. They depend on the degree of the numerator and the degree of the denominator, which you saw in your video that you watched for homework last night. In this case, the degree of the denominator is higher than the degree of the numerator, which means we have got a horizontal asymptote at y equals 0. So now that we have that, we can see the graph is either going to be here or it's going to be here. So the best way to figure that out is to plot some points. Sometimes we have an x-intercept or a y-intercept, and that's just enough information, and we plot that one point, and then we can go from there. For this one, I'm just going to put in 0. Different color. So if I just make an XY chart and I put in 0 for x, I'll put a 0 in. If I put a 0 here, I end up with a 2 in our denominator. Squared is -1/4. So if I plug in 0 for x, I get -1/4 for y. And I just need really 1 point. Because what that tells me, and you just estimate -1/4, it's about there. The graph has to approach the asymptotes. So it's going to look like this. Oh, that's terrible. Let me try that again. I like how no one disagreed with me.
It was really good.
Since the multiplicity of this vertical asymptote is 2, we know that the graph on the other side is going to be going the same direction and approaching the asymptote from the same direction. So we don't really need any points over here. If we weren't sure, then we would just pick another value, which I can't write on my board, but if I -4, I'd try -4 and plug it in for x and see what I get for y. But I already know what's going to happen. See, and we're just estimating, kind of drawing shapes of graphs, and that's it. That's all you need. I knew that the second part of the graph is either going to be up here or up down here. I know it's down here because the multiplicity of this asymptote is 2. It's even. So I knew it was down here. But again, if you didn't have that information, you can just plug in, just pick a value. Just plug in -5 for x and see what you get for y. You're going to get a value down here. If you had a value up here, then you would know the graph would be up here. So you don't really need that many points to graph. You just need the general shape of the function. We are going to move on to number, is that, anyone still writing this down?
I have a question.
Yeah.
What equation did you plug 0 into to get -1/?
Right here. It doesn't really matter. You could do it here as well. But I just, once I factor or simplify or pull a hole out or whatever, then you use the simplified.
I think I put 0 into just like the +2 and then squared part. I didn't do the -1, so I got 4. I was confused.
Oh, because there's a -1 in the numerator. All right, going to number 7. So number 7 and number 9 have the same directions. They ask you to find the vertical, horizontal, and oblique asymptotes, if there are any. So number 7 first needs to be factored. This is x to the 4th minus 1. So we're going to factor that just like we would x squared minus 1. So that's going to be x squared plus 1 and x squared minus 1. Now, x squared plus 1, we can't break that up. That's completely factored. X squared minus 1 is the difference of 2 squares. That's not completely factored. This is x minus 1, x plus 1. So I have to keep factoring. So I'm going to rewrite this, and I'm still just in the denominator. X squared plus 1, x minus 1, x plus 1. Is everybody okay with that factoring? Why I didn't factor the x squared plus 1? Any questions about just factoring in general? We haven't done a lot of factoring, and we haven't done factoring in a while, and you pretty much didn't learn factoring last year. So the last time you saw factoring was Algebra 1. No questions on factoring? Okay, now we can tell the vertical asymptotes are going to be at 1 and -1. There's no vertical asymptote. We can't make this 0 because if I set this factor equal to 0, x squared plus 1, that would mean that x squared would have to be equal to -1, and there's no number times itself that equals -1 that we can graph. Horizontal. Horizontal asymptote, for this one, we look at the degree of the numerator versus the degree of the denominator. The degree of the numerator is less than the degree of the denominator, which is just like the last problem. So that's just going to be y equals 0. I love it when the degrees of the numerator and the denominator are the same, because it's just the leading coefficients for each. So for example, if it said, I don't know, I'm just making stuff up, okay? If it said y equals 3x squared plus 2 over 2x squared plus 1, the these degrees are the same in the numerator and the denominator, so this would be the horizontal asymptote. It's just the leading coefficients. I like it when that happens.
So would it be y equals 3 and 2? Or
3 over 2.
Okay, got it.
Yep. So we've got a horizontal asymptote at x equals 0, and that means we do not have an oblique asymptote. We're going to get to that in the next problem. I wanted to make sure we did one of those. The hardest part about these problems, graphing these, it's the asymptotes. The vertical isn't too bad, but the horizontal gets confusing because the degrees for each of the problems are they're all different. So let's do the tricky one, number 9. First, we start with graphing. because we need to see if there's a hole. If there's a hole and that factor cancels, then there's no vertical asymptote there. Even though if you factor, let's say you factor in the denominators x plus 1, x minus 3, but x plus 1 cancels with the factor in the numerator, then there's no vertical asymptote there, which we're gonna do, I think we're doing a problem like that next class. All right, so denominator needs to be factored again. I'm gonna pull an x out. All right, so I just GCF'd out an x because each of these two terms in our denominator has an x, and so I just unfactored, undistributed, factored out an x. So x times x squared is x cubed, x times 3 is 3x. We good? Now we look at it. We are not going to have a vertical asymptote for this factor because this is a plus 3. There's no way we can make x squared equal to negative 3. However, this x can equal 0. So it doesn't matter if I plug in 0 here and end up with a 3. It's not going to matter because that's going to be multiplied by the 0, which is going to make our denominator 0. And it's going to be undefined there. So we have an asymptote at x equals 0. So all the vertical asymptotes are x equals, and all the horizontal ones are y equals. So now we go to horizontal oblique, and we see that the degree of the numerator is larger than the degree of the denominator. It's a 4, and that's a 3. That tells us we are going to have a slant asymptote or an oblique asymptote. They use those two words interchangeably. So we will not have a horizontal, and we have an oblique, which is good times. Who likes dividing? Anybody? America, I got 0 hands for that. 0. Okay, so when we have to divide the numerator by the denominator. In this case, we're going to have to use long division. And I hope you guys watched my long division versus synthetic division video. You can use synthetic division if you are dividing by like an x plus 2 or an x minus 3, a nice easy factor. However, this denominator is not an x minus 2 or x plus 1. It's an x cubed plus 3x. So we have to use long division. And the way long division works, and I'm going to do that with just regular numbers here. We are doing just from like 4th grade, if I'm dividing, where am I? Okay, 4 into 10. 4 goes into 10 twice. The 2 goes above the 0, right? Because the decimal's right here. So this is an 8, and we subtract it, bring the 2 down, and then if we had another number here, we would bring that down, and we would say 4 goes into 25 times. If we were cutting off the problem here, which we're going to be doing in these examples, right here at the end of the 10, okay? This would be 2, and then there'd be 2 left over, so it's remainder 2, but the 2 goes over the 4. So either way, it's still 2.5, 2 and 2/4. 2 and 2 over what we're dividing by, which is 4, which ends up, if you work through as decimals with real numbers, you'll just get 2.5 anyway, same thing. But now we work with variables and it looks different, but it's the same. So let's try it. So we're going to divide, and I'm going to run out of space here. Maybe yes, down here. 3x to the 4th. Now I don't have any x cubes, so I'm going to put a placeholder there. 0 x cubes. I think I have 0 x squareds as well, and 0 x's plus 4. Now for this particular problem, you don't really need that, but I think just for our sake, because it's easier to have that, because you never know if you might end up with something there, and you want to put these numbers in the right places, just like we did with the 4 and the 10. The 2 went over the 0. We need to do the same thing here. So we need to think, what times x cubed gives me 3x to the 4th? we need what term times x cubed is going to give me 3x to the fourth so that I can cancel 3x to the fourth.
3x.
Okay, so 3x, we got 3x. We're going to put the 3x above where the x's go. In this case, it's going to be above the x's. So I'm going to put it right here. And now I'm going to multiply. 3x times x cubed is 3x to the fourth, and that's going to go underneath the x to the fourths. And then 3x times 3x is 9x squared. I'm going to put that under the x squareds. Now, just like with this 8 when we were subtracting the 8, we did 2 times 4 and we got 8 and we subtracted it. We have to subtract these as well. So I'm going to put in a different color. I'm going to put a subtraction sign, just so I know that I'm subtracting those. Now the end of this number is this 4 right here. So if I need to put anything past this 4, it's going to be a remainder. So what else do I need? I need to find something, hopefully, I may or may not find something, times x cubed plus 3x. Well, let me start over. Something times x cubed is going to give me negative 9x squared. Is there anything? Can I think of anything that I can put above the 4, like a 2 or some number that when I multiply by x cubed, I'm going to be able to cancel out this x squared? There's not going to be anything. Because if I put a number here and I multiply it by a cubed, I'm going to get a cubic, and I need a squared to cancel. So we're done. We're done. So this is going to be cut off right here. Now we could keep going and have a remainder, but if I wrote the remainder, it would, and you'll need the remainder in calculus next year. We won't need it right now, but next year you will need it. The remainder would look like this. So the equation for this oblique asymptote is just y equals 3x. But if I had to write it with the remainder, I would write it like this: minus 9x squared over x cubed plus 3x. We do not need this for pre-calculus. We just need this right here. Any questions on that? That, if you haven't watched the synthetic division versus the long division video, make sure you do that. I think I'm done. Anybody want to say anything about what's going on this week?
Bingo night tonight.
Bingo nights tonight.
Cultural festival.
Cultural festival is talent show is tonight. And when is the cultural festival?
March 24th.
March 24th.
Mm-hmm.
Okay. Peace out. Maybe Justin Bieber will show up to our talent show.
I think he is. He saw my story and stuff.
Probably.
Yeah.
Yeah. Okay. Good. Good.
Yeah, you like